So when we need to perform the independent sample t-test. So independent sample t-test is performed when we have two samples and these samples are not influencing each other. Suppose saying that average height of Punjabis and average height of Jat is significantly similar. So if I want to know whether this statement is correct or not, I need to perform independent sample t-test. So what should I do? I should, as we know that there are 10 crores of Punjabis and there are 12 or 13 crores of Jats. So it's not possible for us to go and check every Punjabis and every Jats. So it's better to do the sampling process. So first I will go to Punjabis. I will collect height of some number of Punjabis and then I will collect the height of some number of Jat, and then I will compare whether the statement which states that average height of Punjabi and average height of Jat is similar, is significantly similar. So so suppose I have collected 21 Punjabis and I have collected 17 Jat, then I will collect their heights. So the 21 Punjabis and 17 Jats, they are independent. Why? Because height of Punjabis is not influenced by the height of Jat, or height of Jat is not being influenced by the Punjabis. So they are totally independent from each other. For that reason, it is called the independent sample t-test. So so we will not consider those samples which are influencing each other. Suppose if I want to calculate the whether the personal quality of personal life and quality of professional life is significantly similar or not. So here we know that quality of personal life is influencing the quality of professional life. So for that reason, in that case, we will not be able to consider the independent sample t-test. We will consider independent sample only when two samples are independent from each other. And why will we do the t-test? Standard deviation of population is unknown. So it's better to show you some real examples so that you can understand. So here is the example. According to a researcher named John, an average patient satisfaction towards private accredited hospital and private non-accredited hospital is similar. To prove it so, another researcher named Paul has studied on 33 patients. Here you can see it's written as 33 patients. He has collected patient satisfaction from them. Among 33 patients, 12 of them have been treated by different private accredited hospitals and 21 of them have been treated by different private non-accredited hospitals. So Paul found that the average patient satisfaction towards private accredited hospital is 4.1 out of 5 and 3.3 out of 5 towards private non-accredited hospital. Standard deviation of patient satisfaction towards private accredited hospital is 0.1 and the standard deviation towards the private non-accredited hospital is 0.15. So the question is, are John's findings and the Paul's finding is similar at 95% confidence level? So here you need to see what we got. So we got two population. First population is the patient of private accredited hospital and the patient of private non-accredited hospital. And we have collected 12 patients from the private accredited hospital and 21 patient from the private non-accredited hospital. So, this is our data, and also we have found the standard deviation. So, standard here you can see this is the standard deviation of the private accredited hospital, which is 0.1, and the standard deviation towards the private non-accredited hospital is 0.15. So, we know the population, we know the sample mean and the standard deviation of sample, but we do not know the standard deviation of the population. And we got the two sample. One is from the private, the patient satisfaction of private accredited hospital and patient satisfaction towards the private non-accredited hospital. So, we need to perform the t-test. Why t-test? Because we do not know the standard deviation of the population. We only know the standard deviation of the sample. So, for that reason we will perform the independent sample t-test. Why independent sample t-test? Because patient satisfaction towards non-accredited private hospital and patient satisfaction towards accredited private hospital is not influencing each other. So, that is why we need to perform the independent sample t-test. And also one more important thing, it is to be noticed that at the end of the question it is saying that at 95% confidence level. So, for that reason we need to remember the 95% confidence level. So, now let us check out the formula of t-test of independent sample t-test. But before going to that part, we need to understand few steps to perform the independent sample t-test. So, first step is that define the null and the alternative hypothesis. So, then it will come the state the alpha level, and then calculate the degree of freedom, then state the decision rules, and then calculate the test statistics, and then state the result, and lastly state the conclusion. So, step 1 is the define the null and alternative hypothesis. So, we write as H naught. H naught is saying that mu 1 equals mu 2. So, if you go back to the question, it is actually saying that patient satisfaction towards private accredited hospital and patient satisfaction towards private non-accredited hospital is similar, is significantly similar. So, for that reason we will write as H naught is saying mu 1 equals mu 2. So, mu 1 means population 1, which means the private accredited hospital, and mu 2 is the population mean of second sample, which is private non-accredited hospital. So, H naught or the null hypothesis is basically saying that mu 1 equals mu 2, and we need to formulate the alternative hypothesis too. So, in that case alternative hypothesis is mu 1 is not equals to mu 2. So, our null hypothesis, so according to our null or H naught is patient satisfaction towards accredited private hospital and non-accredited private hospital is not is significantly different, and in case of alternative hypothesis is the patient satisfaction towards accredited private hospital and non-accredited private hospital is significantly different. So that's how we write the null hypothesis and alternative hypothesis. Null hypothesis is showing as H naught, and alternative hypothesis is showing as H A. So H naught is saying that patient satisfaction towards accredited private hospital and non-accredited private hospital is not significantly different, and alternative hypothesis is showing exactly opposite result. So now so these are all about the step 1. And what about the step 2? Step 2 is the is saying the state the alpha level. So how can we find the alpha level? If you go back to the question, it is saying at the end that finding similar at 95% confidence level. So when it is asked as 95% confidence level, at 95% confidence level alpha is 0.05. If it's saying 99% confidence level, then alpha will be 0.01. So that's how you decide the alpha level depending upon the question. So next step is the calculate the degree of freedom. So when we are calculating the independent sample t-test, when we are doing the calculation of degree of freedom, we need to understand the sample size of two sample. So because in a way to calculate the degree of freedom, we need to understand the sample size of both the sample. If both the sample have equal number of equal sample size, then we need to use different formula, and if when we have unequal sample size of the sample, then we will need a different formula. So in case where unequal sample size, we need to have this formula. Like in our case, we need to use this formula in a way to find out the value of degree of freedom, because we got two sample and sample size is unequal. One sample has if you go to the question, you will find one sample has 12 and 12 sample size. One is having 12 sample size and other is having 21 sample size. So it's clearly stating that we have unequal sample size. So we need to use this formula. This formula is saying that in case of unequal sample size. But when we have equal sample size, then we will use this formula, which is n1 plus n2 minus 2. It's easy, but it's not easy in case where unequal sample size, where we need to use this formula.
So now let's calculate the value of df. df means the degree of freedom. So formula of df is s1 squared divided by n1 whole squared plus s2 squared divided by n2 whole squared whole divided by s1 squared divided by n1 whole squared divided by n1 minus 1 plus s2 squared divided by n2 whole squared divided by n2 minus 1. So, in this case, we need to understand what is the meaning of S1, what is the meaning of S2, what is the meaning of N1 and N2. So, S1 means standard deviation. So, S1 means standard deviation. So, standard deviation of first sample. So, in S1 means standard deviation of first sample. So standard deviation of first sample, and we know that standard deviation of first sample is 0.1, and standard deviation and S2 means standard deviation of second sample, which is 0.15. And N1 means it's a sample size. So sample size of first sample, which is 12, and N2 means sample size of second sample, size of second sample, so which is 21. So now it looks a little complicated, so to make it more easy, so I will first calculate the value of S1 squared divided by N1, then S2 squared divided by N2, and then I will find the square value of this and square value of this. So by that it will be easy to calculate the whole thing. So first let's calculate the value of S1 squared N1, which is S1 squared N1 is 0.1 squared divided by N1 is 12, so it's 12. So that will give 0.01 divided by 12, which ultimately will give 0.000833. And now let's find out the value of S2 squared divided by N2. And we know that value of S2 is 0.15, so 0.15 squared divided by N2, the value of N2 is 21, and it will give 0.0225 divided by 21, and which will give 0.0010714. So we know the value of S1 squared divided by N1 is 0.000083, and S2 squared divided by N2 is 0.0010714. Now let's find out the squared value of these two things. So squared value of S1 squared N1 all squared is 0.000833 squared, and it will give ultimately it will give 0.00006944. So and the value of S2 squared N2 whole squared will be 0.0010714 whole squared, and that ultimately will give 0.000011479. So we know the value of this and this and this and this. So now it will be easy to understand. So now let's put the formula. So formula of df is S1 squared divided by n1 whole squared plus s2 squared divided by n2 whole squared divided by s1 squared divided by n1 whole squared divided by n1 minus 1 plus s2 squared divided by n2 whole squared divided by n2 minus 1. So now we are going to put the value of those things. So we know the value of s1 squared s1 squared divided by n1 whole squared, and the value is 0.000006944 plus we know the value of s2 squared divided by n2 whole squared. We also know the value, and the value is 0.00000111479. Also again we will put this value here, so it's 1.000006944 divided by n1 minus 1. So n1 is as we know that if we go back to the question, we know that n1 is first sample size. So first sample size is 12. So in that case the n1 will be 12 minus 1, that will be 11. And we also know the value of this. So value of this is this. So 0.00000111479 divided by, we also know the n2 is 21. So n2 is 21, so n2 minus 1 will be 20. So now let's find it out. So ultimately it will give 15.28. If you solve this, it will give 15.28. But we will take only 15 because we can't take, in case of degree of freedom, we can't take the fraction number. So we will take 15. Now now let's set the decision rule. So we know the degree of freedom. Degree of freedom is 15. In this case it is 15. And we also know that we need to find out at 95% confidence level. So the critical now we need to understand the critical value. We need to find out the critical value of 95% confidence level where degree of freedom is 15. So how can we do that? So we need to go to the T table. With the help of T table, we will be able to find the value of T crit, or the critical value. So step 4, as we know that step 4 is the state the decision rule. So here you need to mention that in case of 95% confidence level and 15 degree of freedom, the critical value will be we will find out. So the critical value, let's check out how can we find the critical value. So this is the T table. Here you can see it is said that degree of freedom. So these are the degree of freedom, and these are the alpha level. So here you can see our alpha level is 0.05, as we have decided that alpha level will be 0.05. So so first we need to do is to find out the degree of freedom. So our degree of freedom is 15. So we will follow this row, and then we will find the alpha level. So our alpha is 0.05. So we will follow this column. So the area where this row and this column intersect, that will be our critical value. So let's find out. So it is 2.131. So this is our critical value. Suppose we have 10 degree of freedom and our alpha level is 0.01. So in that case, the critical value will be I will follow that the row of 10, and then I will follow this column, and intersecting point will be the critical value. So in that case, 3.169 is the critical value. So that's how you see you find the critical value in the T table. So we know that the T crit is 2.131. So this is the T crit. So T crit means the critical value. So in the step 4 we will find the T crit, and we will write it down that our T crit or T critical value is 2.131. So if the value of T statistic or the T stat exceed the value of T crit, then we will reject the null hypothesis. So if T stat is greater than T crit, then we will reject the null hypothesis. So so this is the rule of thumb. So in this step you need to find out the T crit, the value of T crit, with the help of alpha level and degree of freedom. And you need to mention that as the T crit is 2.131, so if the T stat is greater than the value of T stat is greater than T crit, then we will reject the null hypothesis. It will prove that groups are statistically and significantly different from each other. So now let's do the test statistics. So how can we do the test statistics? So first it's a number 5 level. Number 5 level is the calculate the test statistics. So so here we will find out the formula. We will do the math to find out the T statistics. So formula of T statistics is x bar minus x bar 1 minus x bar 2 minus mu 1 minus mu 2 divided by whole root over s1 squared divided by n1 plus s2 squared divided by n2. So this is the formula. So now let's find out what is the meaning of x bar. So x bar 1, actually x bar 1 is the first sample mean. Is the first sample mean. So first sample mean, what was the first sample mean? It's 4.1. And x bar 2 is the second sample mean. What was that? It was 3.3. And we know the value of this and this, so we don't need to write it down. But the important thing is that these two things, that is mu1 and mu2. So what are they? Actually, mu1 is the population mean, and population mean of two population means. First population mean is mu1 and second population mean was mu2. So but we don't know the value of mu1 and mu2. So what will be the value of this mu1 minus mu2? Well, if you go back to the first step, that is the stating the null and alternative hypothesis, we assumed that our null hypothesis assumed that mu1 equals to mu2. That was our assumption. So we need to use it. So we need to do use these tricks, because we are assuming that mu1 and mu2 is equal. So if it's equal, so we can say mu1 minus mu2 equals to 0. So this part will be used here. So let's find out how can we do it. So first is the let's write the formula again. X bar minus x bar 1 minus x bar 2 minus mu1 minus mu2 divided by whole root over s1 squared n1 plus s2 squared n2. So as I have already mentioned that the value of x bar 1 was 4.1 and x bar 2 was 3.3, and mu1 minus mu2 is 0. So as we have already mentioned in the earlier time. And we also know the value of this and value of this, so I will not calculate this thing again. So instead of that, I will put directly here. That will come to this. Okay. So and ultimately the value of t will be 18.33. So now let's go to the step 6. What was the step 6? Is the state the result. So our result, so the t statistics or t stat is 18.33, and the degree of freedom is 15. So the critical value or the t crit is how much? 2.131. So we can say that t stat is greater than t crit. So that means t stat falls in the rejection region. So we can say that those two groups are significantly different from each other, as the value of t stat is more than the value of t crit. So ultimately state the conclusion state the conclusion. Here what you need to write, you need to write the whole thing. You need to write the problems, and then you need to write why you are doing the independent sample t-test. Then you need to write what was your result. So my result is that the t-stat falls in the rejection region, as the t-stat value is greater than t-cred value, so it falls in the rejection region. So that means groups are statistically and significantly different from each other. And also you need to state in the conclusion part that what was your hypothesis. So your hypothesis was that mu1 equals to mu2. That means patient satisfaction towards accredited hospital and towards non-accredited hospital was not significantly different from each other. That was your hypothesis. You need to write it down. But as the result shows otherwise, for that reason we need to accept that they are not significantly different from each other. So that was the H naught. It is the alternative hypothesis, is the null hypothesis, and this is the alternative hypothesis. So you will reject the null hypothesis and you will accept the alternative hypothesis.